record. Okay, so look it up if you don't know it. Look it up. That's all I'd like you to do. Look it up. So you looked it up. Does anybody have any idea what effective interest rate means? Okay, what happens? Okay, yeah. Stan, what does it mean?
I just assumed that it was the fraction we had in the equation for the compound interest.
You mean the R over N? Yeah. You're close. It is part of it does equate to part of the equation. It's not quite that. What do you think it is, Victor? Same thing? Okay. When you compound a certain amount, if you have 12% and you do it once a year, you get a certain amount of interest, correct? If you do 6% twice, you get more or less. More. If you compound it more and more, you get more interest, correct? Well, let's say I said this, 5.25% compounded monthly, or 5.5% compounded once. Which one will make you more money? Are you sure?
Not really.
No, you're not. You know that by compounding, you will make more money, correct? But if it's a higher interest rate, do you end up with more money if it's just done once? You don't know. So what do you calculate? Effective rate of interest. What would be the equivalent interest rate if you did it once? What would be the equivalent interest rate if you did it once? So for example, let's just pick some values here. Let's pick $100 because I like starting with $100. So let's say you did 5.25 compounded quarterly. 5.25 compounded quarterly for how long do we want to go for? 1 year. Let's go for 1 year. Let's just we can arbitrarily pick this and then we'll generalize, okay? So 5.25%, 1 year. So what's your amount going to be? 100 times what? Yep. To the? Exactly, good. So what are you going to need to use in order to compute that? And this is what we ended up with. So you ended up with how much money? $105 and what? 35 cents. Correct. Right, exactly. You did $105 and 35 cents. What was the percentage gain overall? What did you start with? How much money? You had 100%. Sorry, you had $100, and it turned into 105. $100 turned into $105. So what was the percentage gain? 5 point what? 35. Let's go to 3 decimal places. 4%. So 5.25% compounded quarterly turns into what effective interest rate? Exactly. Meaning, instead, what yearly interest rate would you have to receive to get the exact same amount of interest at the end of the year? That's the question you're answering. What yearly interest rate would you need? What yearly interest rate would you need to receive the same amount of money at the end of the year with interest taken once? So again, 5.25% compounded quarterly turns into what effective interest rate? 5.35. So let's do 5.25% daily. What would that be? $100, right? Plus over what? To the 360. Exactly. We're using 360. You guys watch television? See car ads all the time that say, you know, you get this much down, this is much what you'd have to pay, and this is the interest rate. You know, it's compounded continuously, compounded daily for a certain amount of time. There might be fees associated. When you go out and shop for loans, they have to give you the effective interest rate, the equivalent of the effective interest rate, so that you can do what? Compare. So you can easily compare. Is it really easy to have just a little bit off, but it make a big difference? Right? I mean, I think about it. Over a 30-year loan, how much could a little tiny percentage point matter? A huge amount. A huge amount. So the effective interest rate is how you use to compare loans. Lots of different types of loans? Sure. Okay, so you also wanted to do 24. Is that what I heard? 24 says, what annual rate of interest is required to double an investment in 10 years? So if we do write a formula, do we know what our starting amount is? No, we don't. So again, here is our, this is annual interest rate. So how many times is it being compounded per year? Once. So it's just r to the t. What's your starting amount? Which value is that? Principal p. So what do you want to end up with? What does this so instead of a, what do you write? What do you cross out now?
P.
What do you end up with now?
2 equals parenthesis 1 plus r
To the.
to the power of 2.
And how long do you want this to last for?
10 years.
10 years. So what are you solving for?
Solving for r.
Oh, what kind of equation is that?
It's exponential.
That's an exponential, so what can we convert it to?
Log.
Yay! Log base.
I think.
Okay, 1 plus r of what?
Of 2.
Equals. Do we like having our variable in the denominator? No, we don't. So let's just stop there and ask ourselves, how do we get rid of a 10th power? 10th root. 10th root of 2 equals.
1 plus r.
So what does r equal? 2 to the 1/10 minus.
1.
And if you do that out, 2 to the 0.1 minus what? 1? That's 2 to the 0.1, by the way. So what's the annual interest rate you need? 7.18%. So if you received a 7.18% interest rate annually, it would double after 10 years. Cool? I'm sorry, what multiply what by 100? To get from decimal to percent? Yes. Yes. Yes, absolutely. Okay, other questions from here through 36.
There is a 30.
33? How many people like 33?
Yeah.
Or don't like it? You know, what don't you like about 33?
Continuation?
Could someone give me a sentence with maybe a verb in it?
It compounded continuously instead of compounded in.
Okay, it says, how many years will it take for an initial investment of $10,000 to grow to $25,000? Assume interest rate of 6% compounded continuously. So, what's the equation for continuous interest? A equals what? Pert, right? Which 10,000 represents A or P? P. What's the interest rate?
0.06.
We don't know T, right? And what's that equal?
Equals 5.
Yeah. Okay, so what are we solving for? Okay, what should we do first? Thank you. Somebody, I don't know what to do. The numbers are too big. No, they're not. They're not really that big, right? So what do you end up with? 5 over 2 is equal to e to the...
0.06.
Yeah, exactly. How do I solve for this? What do I do?
Logarithm.
Yeah, let's just take the... do you want to translate to log form?
Yeah.
Yeah, log base
E.
of
5 over 2.
equals
T. 0.06.
t. So if you want to write this out, t is equal to ln of 2.5 all over. And if you do this out, you get what ln of 2.5, enter, divided by
15 years.
So if you have the annual interest rate of 6% compounded continuously, it'll take you 15.27 years to get from $10,000 to $25,000. Does that make sense? So are logs pretty important in taking a look at these problems? Yeah. What about exponents?
Usually
Yeah. Are they pretty much one and the same thing? They are one and the same thing. Sometimes one will be useful, sometimes the other will be useful. Any last questions on these first 36? 36? How many people want to see 36? Got a couple? 36 or 30? Anybody care? 36? Okay. This will be the last one of this group. Okay, so it says Sears charges 1.25% on the unpaid balance for customers with charge accounts. What do they mean by a charge account? Credit card, yeah, exactly. Interesting note, everybody. As of, I think, later this year, there will be more student debt in the United States than credit card debt. Yeah. And here, do you want to see something scary? We'll look this up later. Think of this in your head. What do you think if you look at all of the credit card debt in the United States? What's the average amount of credit card debt the average American has? Just think of it. Don't even say it out loud. Think about that in the next 5-10 minutes. We'll look it up. We'll see. We'll have a contest. See who gets it right. Okay. So, a customer charges $200 and does not pay your bill for 6 months. What is the bill at that time? Kids, here we go. Hold on. So it's 1.25% per month on unpaid balance, and it's $200 and does not pay your bill for 6 months. So the amount is going to equal, how much does it start at? 200 times 1 plus, what do we put for the interest rate? Divided by 12 to the 6. Yeah. Well, you both said the same thing. 0.5 times what? Times 12. Exactly. Good. So if you actually do this out, we interpreted the data wrong. The 12, well, there's a problem in the vicinity of the 12.
The 0.0125
Yep.
doesn't need to divide it by 12.
You don't need to divide it by 12. Why?
Because it's charged monthly.
Yeah, look what they say here, guys.
It's charged monthly
Take a look at this. This looks like a low interest rate, right? But what does it say right next to it?
per month.
Per month. When you look at interest rates, 99% of the time, what's the interest rate done in?
It's annual.
Yearly, right? Annually. At 1.25% per month, what is that annually, if you wanted to think about it annually?
It's times 12 divided by
That's a 15% interest rate. That's a 15% interest rate. Yearly, right? 15%. So, how do we fix this? How do we fix this? Get rid of the divided by 12. So your amount is actually going to be 200 times 1.0125 to the 6.
You keep that 12 in the exponent.
Yes, you keep the 12 in the exponent because you're compounding it 6 times. If you don't multiply times 12, you're only multiplying it by half a month.
Yeah.
So the way they made that nasty there is they said it's 1.25% per month. Think about that. In your head, you're like, oh, wow, 1.25% a month. Because you guys get hardwired for, like, a bank account with 6 or 7%, or credit cards, which are terrible. Don't even think about credit cards. But what is that in actuality? It's more in your head, what should you really be thinking of 1.25% per month? You should be thinking of it as what? 15% in a year. So does that effective interest rate make a lot more sense? Yeah, it does. It really does. Also, 1.25% per month. Yeah, 15%. It seems pretty high. Is that pretty traditional for a credit card? Yeah, 15% is for a credit card. Yeah, it's nasty. Credit cards, it's not unheard of to be 20% or higher. What does that come out to be? 200 and what?
0.48.
0.48?
Yeah.
Yeah. What kinds of customers do credit card companies like the most? What? It's a really simple answer. What is the effective interest rate on the first one?
12%.
Yeah, the effective interest rate on the first one is 12%. That is the definition of effective interest rate. What is the yearly interest rate? So the first one is 12%. So could someone tell me, I gave you that formula before, it's really just the 1 plus point what? Oh, I'm sorry. Yeah, if you fill in the values, I'm sorry. I wasn't clear there. Go ahead. Point
1125. Oh, 5.
5 over what?
12
Over 12.
times.
I thought we decided we just shouldn't put it over 12.
No. It was only in that case.
Oh.
It was only in that case because it said 1.25 monthly. It said 1.25 monthly. This is 100%. When they just give you the interest rate and they don't say anything else, it's always yearly.
Okay.
They promise to pay the seller $5,000. Okay, to 12. To the what power? To the 12. You do it for 1 year. You do it for 1 year. For 1 year. How important is this information right here in this problem?
Not very.
When you say not very, how important is it? It doesn't matter at all. All of that information is basically junk. Do you actually use the 150,000 to 50,000 to 5 years? No. You're just comparing the interest rates, right? It's like, I went to the store, I drove my car, what was the speed limit, right? Does the car going to the store matter at all? Not at all. Okay, so that's the effective interest rate. That would, and then what do we subtract? 1. And then what's the effective interest rate on C? 1 plus. Oh, no, compounded continuously, right?
Yeah, so
We have this. Let's do this first one. Can someone do out that first one and tell me what it is, and then we'll move on? Not that important to you. Like, do you really care what the Dow Jones Industrial Average, the hours or the Nikkei is at? Not really. You also hear things about like the Fed changing interest rates. When the Fed changes interest rates, you already know what A is. What is A? The amount of the payment. P, principal. So you can think of that as the loan amount. Like, how much did you borrow? I'm putting this kind of in a real life situation for you. This can be malleable, but let's be specific. You know what N is? What's N? Number of, this is going to be number of payments, okay? We have to be, there's different ways to write this formula. I'm trying to write it the cleanest way possible and modify what the variables are, because if I don't modify what the variables are, the formula becomes a little bit disgusting. R, what's R?
rate in decimal.
Yeah, rate is always in decimal. Do fun things happen if you don't write it in decimal? Yeah. Rate in decimal. Now I, this is the one thing, we're calling this the periodic interest rate. What that means is that's R over, so for example, periodic interest rate would be the interest rate divided by 12 if you were doing monthly payments. So it's the part of interest per interval. What's the most common interval on amortization? Like when you're amortizing a loan, what's the most common interval? Car loans are usually what? Home loans are usually, no. Home loans you pay by every what? Every month. Monthly is going to be the most common one by far. By far. So let's come up with, what are we going to buy? We're going to buy a house or a car? Let's do a car, okay? What could be, let's just do a car because it's probably a little more immediate for you guys. How much is our car going to cost? $15,000? So the German, so cheap. What's our interest rate going to be? Let's say 6%. That's reasonable. Let's say 6%. So what is it going to be? 0.06. How long is our loan for? 5 years. And we're going to do monthly. 5 years monthly. So how many payments are there? 60. What is our I value going to be? If it's 6% monthly, it's going to be 0.06 divided by what? 12 monthly. So it's per, like the piece per month is what we're thinking about. When we verbalize percentage rates, it's always, when we have the choice, yearly. So what's it going to be over? 1 plus 0.06 to the... Nope. Nope. Oh, I'm sorry. You're absolutely right. 0.06 over 12 minus 1. Okay, everybody, sorry. This right here, that right there, is supposed to be an I. Sorry about that. The R is in the I. So what is this? Yes, 0.06 over 12. Sorry about that. So one way you can do this, should you type that whole thing into your calculator all at once? Please don't do that. It's a really bad way to go about doing this. This is how I would do it. 0.06 divided by 12. I would do that first on my calculator. 0.06 divided by 12. 0.005. And I'm going to store that as alpha A. Every time I type A, what is it? 0.005. Store. STO. STO. So what am I going to type out now? 15,000. You just need to remember your formula. Let's do the top first. So 15,000 times what? 1 plus. Oop, it'd be nice if I did 1 plus alpha A to the what power? I'm going to press enter on that, and I'm going to divide it by. What am I dividing it by? And there's that minus 1 at the end, so I need to make a parenthesis. Let's do double parenthesis. 1 plus what? To the minus 1. Whoops. What seems to be the problem? Oh, do you know what I missed? What's missing right there? 0.005 on the top. So this is actually much too large. So what should I just multiply it by? I forgot that. Does that make more sense? Yes, that makes a lot more sense. Let me cut that in. Sorry about that, kids. So what does that mean? Can someone just tell me what we just found out? Sorry, say that louder. That's our monthly payment. So this amount right here, guys, can you stop talking over there? I hear you constantly. So $289 and actually what's really close to what? That's really close. So $290 a month. So if you have a $15,000 car, what are your monthly payments going to be for 5 years? Does that sound about what you think should be in your head? Yeah, even though you haven't had to do this yet, some of you should have a pretty good idea because you're blasted every second on car commercials. This is what it's going to cost per month, per month, per month. Should you ever really lease a car? Please don't lease a car. Please don't lease a car. You don't even get it at the end of the time. You might have an option to buy, but just don't. So typing this out in your calculator, just be really careful. Be really careful. And I think it's programmed somewhere into your calculator. There's like an easier way to type it in, but I can't remember where it is. So you'd have to look. Let's do one more situation. What are we going to buy now? A house? How much is our house going to cost? $1 million? Okay, $1 million house. $1 million house, okay. That would buy 2 mansions in St. Johnsbury, okay. So we have 1 million times, what's our interest rate going to be? So let's say 5%, sure. And we'll do 30 years. My question is going to be, what's your monthly payments? What's your monthly payments? Yeah, I think this whole thing and this whole thing is the same thing twice, right? Yeah. So what you could actually do is this. You could do, yes, 1 plus 0.05 divided by what? To the 360. Is that correct? And store it as what? A. So now what do you have? 1 million. Oh, let's multiply 1 million at the end. So it's going to be, if we look at this, it's going to be 0.05 divided by 12 times A divided by A minus 1. Is that a little bit easier to type in? Yeah. 0.05 divided by 12 times what? A divided by A minus what? Times what? Times 1, 2, 3, 4, 5, 6. Nice. Good job. Yes, what? So if you want to own a house that costs $1 million, there you go. Yes.
So when I get that number minus 1, it gets to negative.
Then you typed in something wrong. We just did it out. Was it negative? No. Our A value was 4.46 something. Then I don't know what your problem is. I'd have to look. I don't understand it right now. You end up paying almost $2 million on a $1 million house. Is that totally normal, everybody? Yeah. You can expect to pay double the amount of the value of the loan over time.